Hey guys, it's Reed here, and this is episode 29 of Contest Coding. This is probably the hardest problem we've done on this show to date, so it's going to be a little bit interesting, and the best advice I can really give you for this one is just to memorize the algorithm, because it's pretty confusing if you're not super strong at learning how these things work. So best strategy for this one is just to memorize the algorithm I'm going to give you. And that's how I solve a lot of problems. I just memorize the algorithm once, and then you just use it every time you see the similar problem. This problem is usually used with coins, but in this case they're actually using darts, and it's going to be a summing up the different possibilities to score a certain amount of points, like 41 points, given the denominations they give you. So the first thing you have to do is you have to load your denominations in. This could be really hard because there's actually a lot of denominations. You're going to have every integer is 1 to 20, multiples of 2 from 2 to 40, multiples of 3, 3 to 60, 50, 25, bunch of different denominations. You miss one, you're not going to get the problem right. So you have to make sure you get everything loaded in. So I'm going to show you the trick that I use to get this done. I'm going to call it vals. I'm going to make a tree set so I don't have to worry about duplicates, because you don't want duplicates when you're doing this. It'll just make your life even harder. And I'm going to add the odd numbers that are not odd, they're multiples of 25 that are just special ones, like the bullseye values. Then I'm going to do a for loop equals 1, because you don't ever need 0. I is less than or equal to 20, I plus plus. And what I'm going to do is I'm just going to do vals.add I, vals.add I times 2, and vals.add I times 3, like that. And then it should load everything I want into my tree set. But then I'm going to need an integer array to make it a little bit easier, so it's an ordered and I don't have any crazy numbers in there. It's easy to just access objects at the index. So this is going to be my point vals array, which are the key values or commonly used as denominations when dealing with coins. And what I'm going to do here is just make a new integer array of vals.size. Instantiate that. I'm going to make an index variable. And then while my vals.size is greater than 0, I'm just going to start pulling the front. So I'm going to do point vals index plus plus equals vals.pull first, like that. And it's going to start pulling off the front of the list, so it'll be in increasing order starting at 0 in my point vals array. Then comes the tricky part where you have to write the algorithm that's going to solve the problem. First, you need to get your key value read in. So we're going to get key equals send.next, int, like that. Then we're going to make our matrix, which is the solution algorithm that we're going to use. It's like having a matrix, and it's kind of dynamic programming is the technical term for it. But basically, you're just assuming that the problems before you have been already solved, so you don't have to worry about anything else that is tricky. And we know this needs to be the length of our denominations or point vals array, like this. And we need to make sure it has the second length to be the key plus 1 for the different numbers that are going to add up to be it. Plus 1 because you start at 0 and you're going to not really refer to 0 that often. You're going to start your indexes at 1 and it's going to work better in case you go over. Just make it bigger. If you want to put plus 2, it would work too. You just want to make it big enough so that you don't go over and have any out of bounds errors. That's the trick to making sure when you're pulling numbers like this, if as long as bigger is better, because adding 1 or 2 or even 5 to the end of your matrix won't matter that much. It matters a lot though whenever you start getting errors that throw it out of bounds, so you just don't want to have to worry about that. Then we're going to start by going through and instantiating this matrix with the starting values that we want it to have. So in the algorithm, what you have to do is you're just going through matrix 0.length, so you're going all the way across the bottom. Or I guess it looks like it could be the top depending on how you look at it. And all you're going to do is just load up mat 0i equals I. Just load up the initial values of the indexes going down the list. Not too tricky, just enough to get it so that all the way up and down on the first row it's filled in with the numbers that it can be accessed to as the key or the 0. So it's going to be like 0, 0. Actually, I'll print this out real quick for you so you can actually see what it's going to look like. Out.print. We'll do, like this. Mat 0. Like that. So terminal javac darts.java java darts. Hopefully this will compile and work. Okay, so there we have it. Lots of numbers there, but this is for all 3 problems, so we're really only going to look at one real quick. So if we go long enough, you see there's one line right there, 0, 1, 2, 3, 4, just incrementing all the way up to 41, which is the first value. Pretty simple, right? Starts at 0, goes all the way up to 41, incrementing the values all the way down the list. So that's what they're going to look like right now whenever we did the instantiation of your matrix. And get rid of that line of code right there. And we'll keep going. So next what we're going to have to go through is go through the entire set of point vals in a nested for loop. So int I equals 1, I is less than point vals.length, which is your different values that you're going to have, which I can print that out too real quick. And I'll just put it in, could put a return there. I'm not going to worry about that. Hopefully it will compile like this. Java darts, and there we have it. Those are your different point vals, 1, 2, 3, 4, all the way up to 60 at different increments. So that's what we're looping through now. Make sure you have, we'll get rid of that. Okay, and then we're going to go through another for loop. Int j equals 0. J is less than key plus 1. There you see the plus 1 again, keeping everything in bounds. J plus plus. So you have your key that you're going to go through from 0 to the key value, which say in the first one is going to be 41. You want to go loop all the way through those for all the point value denominations. Looking pretty it's looking pretty traditional right now. And we have our current value, which is going to be j. No surprise there. Then we also have the last value, which is going to be stored in our matrix at I minus 1 j, like that. And then we have our difference between the current and point vals of I, which is going to decide which location you look up in the matrix on the next step. So first, if difference is greater than or equal to 0, we have to make sure, so as long as it's not negative, point vals I, like that, is also less than cur, which is your current value. We need to make sure we have the next step, which is getting your temporary value, which is what you're testing, point vals I plus the matrix I, and then the difference. So you're adding it together to make sure you get to your key value now, because you don't know if it hits the key yet. Then we have to see, let's see, does this equal our key? So if temp is less than or equal to key, meaning it hasn't gone over the max value that we have, we want to also check if 1 plus matrix I difference, so this is the solution to the last one, how many steps it's taken. If 1 plus that, so another step is less than last, which is the last solution we had. If that all works out, we're going to do matrix I j equals 1 plus matrix I difference, like that. So that's setting the new one to that if it's less and it works out properly. And if it doesn't, we just use the last one. So we set matrix I j to last, which is the last solution we had, so it's still the lowest. Then if you go down here, we have to finish up this if statement, same thing as before. If it misses or it fails the check, you set it to the last value. Then if once the loop runs through several times or a lot of times, what it's going to do is it's going to pop out the answer, and the answer is going to be located at the farthest corner of your matrix. So it's going to be matrix mat.length minus 1 and matrix 0.length minus 1, like that. And there are a couple of good guides online you can read about how to actually do this algorithm. Those are where I researched it, trying to figure out how to make it really efficient, how to make this work. So if you read them, they kind of explain it to you a little bit better than I can because they're professional algorithm people. But you'll see once you run it, it'll turn out as 2, 6, 1, the correct answers, and it's really fast too. You're thinking it's going to go through this entire matrix, this down, however many matrix levels it has to go down by, which is point vals.length, so it's going to be like 60 down and 300 across. It's going through all those things, filling them in for you. So it's pretty fast that it can do all that because you have all these if statements that just kick it out and keep storing the last value. So it's only doing small calculations. Hopefully this is a little bit clearer for you. The best thing I'd say is just try to memorize this. You know you have to have your matrix. Make sure you instantiate the first row like this with your i's and your indexes all lined up like that. Then you have your double for loop. Check your current values, your last value, your difference value. You gotta make sure you store those. Then you just start checking and make sure it doesn't kick it over the edge. When I say kick it over the edge, I mean that it's going beyond the key value, and you don't want that where it's going too low, the difference is negative, then it means it doesn't work either. So that's why you have these little boundary conditions. If the boundary conditions work, then you just start storing it as 1 plus it, and you're good. Hopefully this will clarify this problem. It's probably the hardest one I've done, so if it doesn't make sense, sorry, and there might be a lot better solutions than the one I have. This is just what I'm going to do when I do them. And typically when you are solving these types of problems, like the coin ones, or I guess in this case darts, It's usually better to just do the couple for loops, but in this case it was a huge amount of denomination, so it was just impossible to write that many for loops. Hopefully this helped you guys. If you have any more questions, send me a message. Thanks for watching.